Hello, everyone. Welcome you come to our symposium series again. So that is a rewarding international large-scale educational assessment with multimodal process data symposium series. So today we're very happy and honored to invite the three great speakers to join us. So the series name is Series 3, Validity, Theory, and Ethics of Process Data in Large-Scale Assessment. It is organized by me. My name is Qiwei Britt in Georgetown University, and also Dr. David Pepper from King's College, London. So you see, this is our third theories. Actually, is also marked as the last one in the theories between the collaboration with Georgetown University and King's College, London. So we hope that you enjoy this journey as much as we do. Actually, we enjoy that very much. So let's come into today's session. So the first acknowledgements to the Georgetown and King's College Joint Seed Fund to support us to have this online symposium and also have the mutual visit between me and also David. So we really appreciate this kind of a support and to share this knowledge around this kind of community.
At a time, it looks like there's a lot of information here, but these subsections are quite small. There's a couple of themes I want to highlight at the beginning for you to sort of foreshadow. The first is, let's start with the more particular one first, which is what I've been fascinated looking at the whole field, this whole field of process data, and is the fact that we are in some ways reenacting some of our histories, and you'll see what I talk about here in a few moments. We are reenacting some of our history in here, and I think it's important to remind ourselves of that. The other point that I'm going to mention is I'm going to talk about explanation, but actually, given the time limits, I'm going to de-emphasize that, send you to some reading and some papers of mine that are coming out right now. I look at explanation just as something ahead of time. I don't take I take a position that's more sort of an abductive form of reasoning, and I don't cast it as a theory ahead or theory after in the same way. But I certainly appreciate that idea, but I really think about abductive methods, and a lot of what I call explanation is really inference to the best explanation. I'm trained as a mathematician, but over the decades of doing the work of this field, I've spent a great deal of time working with philosophers of science and taken sabbaticals and been a visiting professor in some institutes in philosophy of science at Berkeley, Stanford, and there at Cambridge, actually. And so it's been very exciting to me to sort of see both of these things. Last overarching theme, I think, that becomes important is the importance of epistemic humility in all of this. As a field, not as individuals. As a field, the epistemic humility sometimes gets set aside, and we'll come back to that idea at some other time if you want towards the end of what I mean by it. All right, so very quickly, there's a few things I want to say. These have been made, so I'll go through them quickly. By others, this is something that Javier mentioned, is this notion of the distinction between process and product in computer-based assessment. It's a paper by myself, Brian Maddox, and Naomi Kerr in 2023 on that theme issue in the European Journal, where we began to sort of do some conceptual work there, clearing the ground around what we mean by process and product. So we dealt with some foundational issues, and we brought in the notion score interpretation and validation. I've heard some of it, I've heard it mentioned, but I've not heard it front and center. So some key points today is address the long-standing distinction, process and product, a distinction that remained relatively stable until the digital transition, really. Product, as we've said, is the given answer to the task or question of the on the assessment, and the process is how the respondent arrived at it. There's actually process, and what it is and how to define it becomes quite interesting in this paper and a bit today as well. Following Cronbach, Emil's framework, Goldham et al. In 2021, Maddox in 2023, and Maddox, myself, and Kerr in 2023, we distinguish two broad classes of constructs, right? In this computer-based assessment, each of which pause for dramatic effect, each of which requires its own validation effort. No one seems upset. Did the count go down, David, as the number of attendees? Test constructs reflected in the product, right? We've got decades. Well, actually, I did this monograph in 2023. I traced the history and did some work at looking at have we come up with different models and different frameworks for validation. We actually do have one that's shook out, but it's at the macro level. It's explanation-focused approach, not too surprising. That's my own. And if Javier accuses me of confirmation bias, I will follow him to Spain, drink wine, and eat lots of food until I persuade him that I am correct. So one of you smiled. So the point here is that we've got 125 years of that. Some of it's useful, some of it's not. Some of it's esoteric, some of it isn't. But we've got 125 years of it. But with process constructs, we're now beginning to take that and say, okay, how can we now use what we've learned over 125 years of validity theory, if you wish to call it that, although there's not much there, and look at process data, right? And because we are making claims, we're making claims, and so therefore, we now begin to ask that question, and it becomes quite, and that's what I want to talk a little bit about today. I'm going to introduce some methodological approaches, and I want to take a look a little bit at some strategies that way. Again, controversial question. Should we focus on process data or response processes? That may seem unimportant and nuanced or subtle for some of you. It's not. It's actually a fundamental issue. And I want to acknowledge this is partly shaped, although not exclusively, he's not responsible for anything you disagree with my work with Brian Maddox. I mean, are we talking about process data or response processes? In the philosophy of science literature, there's discussions of this sort of concept that goes back at least, 70 years or more, maybe even a bit longer than that. Is the discussion around the data, around the phenomena, if you wish? The most recent variation of this is Bogan and Woodward in the philosophy of science literature. I think that's probably the most recent, although there are others. And there's a paper that I've been noodling with for a while, just about finished, that I try and take this notion apart. Are we looking at data, or are we looking at response processes themselves? We observe that conceptualizations of response processes themselves are actually rarely articulated. It's not zero. There are people doing good work on it. My former UBC colleague, still my UBC colleague in my art, Kadri Ersakan, has done some work on this. I've done some work with Anita Hubley on this. Brian Maddox has done beautiful work around this. Others have as well. And the idea is, for the most part, it's as the speaker before me, Javier, said, it's sort of got this sort of data first kind of feel to it, right? It's got this data first, and it's often, when it's even discussed, it's from statistical models. Listen, I love the statistical models. That's not the issue. It's my home originally as a pure mathematician, then later as a probabilist and statistician. I love that kind of work. I still do it. I've published recent papers around it in measurement journals. But the problem is that we run into the issue of conflating method and methodology. And we've, just like we have historically conflated validity, the theory, with validation. And so we need to be careful about how how we sort of lose ourselves in the data, and it comes back again and repeating history. Well, this sort of data first. Originally, if you begin to think about what I would describe as response processes, actually, it's the earliest work in experimental psychology. In the 2023 paper in the European Journal with Brian and I, and we actually begin with some of the earliest work. Saul Sternberg, the other Sternberg, not Bob Sternberg. But this has been going on since the late 1800s or earlier. It's the root, if you wish. It's the basis of what was important a lot in experimental psychology. That was theory heavy, theory first. Now we've swung the other way and moved to data first. Well, this issue becomes important. Today, of course, as you're all there, in terms of digital traces, you can see the kind of data that's being seen there. These data sources capture the observable actions that test takers perform while completing interactive computer-based items. Caution. These are observable actions. That is chosen as a phrase I want to highlight, because what we're doing in our reenactment of our histories is we begin to sort of reify, breathe life into, and give intention to what is a behavioral click, a movement of an eye. All of a sudden, we're giving all kinds of intentionality, and then we label them. We say, oh, there is someone who is slow. Again, there's a paper that's under review with Brian and I. And I mention him often now, Brian, just step in when you want and set me straight on any of this. But here, what's interesting around here is, let's not forget what we're doing. And in the fact that we, in some senses, are reenacting our histories, right? And the history of the discipline, the histories of people. But we see this behavior, and we've done it in anthropology, psychology, sociology, all of these areas, all the human aspects of our studies. And we see something happen, and suddenly we put on them this sort of intentionality, this motivation, and we give them a label. And now we're getting into some murky parts of the world. I'm not going to go, I've pretty much said a lot of this, is that the problem is that we conflate process data with response processes, and they are not the same thing. They're not the same thing. The reason they're not the same thing is because we're, in a sense, saving, as Borgen Woodward would say, we are saving the phenomena. The phenomena, in this case, construct, if that makes you more comfortable, the phenomena is response processes. The data is process data. To conflate them is a category error. And one, again, as human beings, we make all of the time. There's nothing wrong with errors. There better not be. I make them 25 a second. There's nothing wrong with errors. There is a problem with errors if we lose our epistemic humility. So it obscures the role, and in doing so, we obscure the role of construct validity, right? Take-home message, data do not explain themselves. Oh, what's going on here? Phenomena, constructs, go back, read Cronbach-Emile, read the McCorker-Dale-Emile, take a look at it. Constructs, phenomena had two, and there still are two general ways that people think about them. One is that they think of constructs, phenomena, attributes, or whatever you want to call them, as summaries of observable behaviors. So we get mouse clicks, eye movements, right? And we get a time sequence, a stochastic process of it. And all of a sudden, a construct is a summary statement, right? Sort of an average, some sort of complicated sort of a weighted function, if you wish, conceptually. Other individuals, and probably the clearest statement is that the phenomena explains, as Cronbach-Emile would say, explains the test performance. The phenomena explains the test phenomena. The construct has, I can't speak of the explanatory turn to validity theory. It's a paper of mine coming out in the new year, in self-report measures, and that where I remind us of the explanatory turn in our field was 1955 Cronbeck and Meehl. That's what made Cronbeck and Meehl revolutionary. It was no longer this descriptive empiricism. It was an explanatory empiricism. And the explanation is governed by, is shaped in part, in whole, people argued, by the phenomena, the construct itself. Well, that means that data and construct need to be separate. Why? Because something cannot explain itself. So data, a construct cannot explain itself. Data cannot explain itself. They need to be separated. They're not the same. And then now we no longer risk this conflation. And in fact, now we have an explanatory theory. I actually take it a bit further. In my explanation, I go beyond the construct itself. A couple of clicks here. I just want to give you an I'll gladly send this to anyone who wishes. Core mistake is one that we're doing. There's our history all over again. It's a core mistake in operational definitions in psychology, was treating the means of knowing a construct, phenomena, that is the operation, as identical with the construct itself, the phenomena. This confusion between epistemic access, how we measure, and ontological status, what exists, produced a century of conceptual flattening. Intelligence became whatever intelligence tests measure. That seems kind of silly, doesn't it? Well, parallel this one. Unmotivated respondents become a test taker whose time at test is the far tail of the time distribution. Linguistically, those have a great deal of parallel. It's just as an empty a statement as whatever IQ tests measure is intelligence. They have a linguistic parallel there. Subtle distinctions, we put some nuance to it, but an unmotivated respondent is someone, and then we say they're malingering, they're not interested, there's cultural differences, right? They come from the deep south of Italy, where Bruno is from, and we take it cool and slow down there, right? All of a sudden, we start redoing and reliving a sociology of knowledge, which is problematic. We haven't gone so far yet, as Javier said, reckoning our history, but boy, oh boy, things are going sort of the 49th parallel where I live. We're not far away, and if you don't know what I'm referring to, turn the news on. This was not a minor definitional slip. This is a category error. And this is important. Now, do I say everyone's doing it? No, it's tied to that epistemic humility. It's tied to go back and say, hold it, are we doing this? And then becomes dogma. And there's many papers. Why? Because we have log manual files, psychometric norms. It's easy to quantify, right? We got process objects, we've got techniques, we've got fast Fourier transforms. We have all kinds of things we can do. Stochastic modeling. But all of these advantages came at a massive theoretical cost. Conceptual reification, and treating task-dependent observables as the phenomena itself. Very briefly here, I want to show you a little bit of a different way of thinking about constructs, because I'm using the work, and I'm almost certain, almost certain that my friend Danny Boyce has already written about this topic, mostly because I'm historically about 3.5 years or 3.5 decades behind him in my thinking, and he's so smart and prolific. But I don't always agree with him, which makes me a little happy, I guess, because I'm behind, but not always in agreement. So what I'm going to describe is conceptual embedding. Perhaps others have written about it. I couldn't find any, but let me show you what I mean by construct. In general, what we need to think about is that observed and latent scores must remain distinct from constructs or the phenomena, right? So process data is not the same as response processes. They're distinct, related but distinct. In general, the relationship can be expressed in this manner here, which situates observed in this manner here, T, observed score, true score are elements of this this object, this set called script C, which situates observed and true scores within the construct without assuming a directional mapping. It also stresses that XT and the constructs shared embedding in the construct space while avoiding any assumptions of directionality. So where you're making inferences from the observed to a latent score or true score, or in fact, the other kind where you actually make the other direction from true to an observed score in the more generative modeling, which is really what the form of IRT is looked at. Core claim constructs are interpretive frameworks, not literal score assignments, right? They are grounded in empirical relational structures. I don't go where, this is a similar field to Cronbach and Meehl, except I don't use nomological networks, which is a very powerful idea in 1955, early 1950s. I don't go nomological network. I actually think about it, as others do, as empirical relational structures. And these are explanatory entities. And it's hard to, how do you say to a student or to a colleague, well, we have a phenomenon, we have a construct, we have an attribute, but you don't actually think of it as a score on the attribute. We can think of a status, we can think of, but it's not a score. Therefore, the phrase construct reliability, to me, is a complicated idea that I've never gotten my head around. If you don't get a score, it's not a mapping. You don't have a probability space, where it's defined in a particular way. So it really has some confusion around it. These empirical relational structures provide the foundation that gives constructs their meaning. There's some contemporary versions, mine's only one of them, where anchors psychometric inference. There's implications for interpretation. There's no scores on a construct. The scores function is indicators situated within the broader networks of meaning. Valid interpretation depends on the coherence of these networks, not on the numerical values alone. And now I'm thinking about process. So the phenomena is response processes, response process data. You're making an inference, a claim about response processes. And the idea of this coherence becomes important. It's very important to apply. So let's say a nuanced difference can be illustrated with a fictitious educational assessment of a construct. Quantitative reasoning, QR, using the quant assessment. If you find it online, it's owned by me, and all money will go directly to David Pepper's, Dr. Pepper's fund to make London great again. How does that sound? I like David. So here now, the empirical relational system is defined in this more, I try and give some formalism. It's where I come from as a mathematician. I try and give some of it. So I denote E sub 1 to E sub k. Each E sub I is an evidential outcome of some sort. I mean, Susan Everton was doing this beautiful work in the 1970s, and important work being done by it. Again, an explanation-focused theoretician and practitioner. But you've got this set S of evidence, reliability. You're making a claim from an observed score to a latent score, right? And you're capturing the true score information mathematically from the theories most I've been writing about for several decades, but most recent papers of mine, you're defining an operator theoretic model, which you have a projection from your observed score to a true score, and you're defining a sigma algebra, which is all of the possible outcomes and influences, to a sub-sigma algebra, which is some set of them, for response processes. Reliability corresponds to that. Validity, though, is a bit more complicated. Reliability is an internal or uncertainty, if you wish, uncertainty in the observed score is that function here mapped from, but a particular kind of mapping from this evidence set to the construct space. So the quant measure so it's some process data around the quant measure to response processes as a construct, which projects the empirical evidence into the construct space. The arrow, the one that was used for uncertainty, specifies a function or a mapping, a morphism between sets or spaces, and that I think is very useful. We have a deep sense of it. In contrast, the maps to arrow is the action of a function on elements with such elements of the set, this evidence, is sent to the elements of the construct space, specifying what happens to individual elements under the mapping. And in those elements are moral, ethical issues. David, stop me when I'm running out of time, because I'll just keep going. Unlike reliability, validity is not computed directly, but integrates evidence into theoretical claims about constructs.
You're just coming up to half an hour, Bruno, so we better ask you to wrap it up.
I've got half an hour left? That's beautiful.
No, you'd had half an hour, so I've let you
Okay, so I'm way over. I'll wrap it up quickly then. So what do I want to say on shedding light on process data? Well, I talk about this mapping. I developed I tried to develop this validity function or validity mapping. I again, coming out of my history, my compulsion is I have to give you some properties of this mapping. And remember what it means for validity to be warranted. First, it has to be well defined, logically coherent. Every element must map to some construct interpretation. Mapping cannot be ambiguous or internally inconsistent. Scores are unstable, a lot of uncertainty. Implication is without sufficient reliability or without sufficient control over the uncertainty, validity doesn't get off the ground. We have a variation of that idea in classical test theory, but that is actually an outcome of a definition of a Pearsonian covariance, right? Second, the construct needs to be irreducible. There's a non-triviality. It cannot collapse into tautological. For those of you who study some math, we're now going into an area of mathematics that, can you have empty sets, etc. Can it map onto itself? It corresponds to meaningful, distinct, and it has to add explanatory value. The third element, and there's only 4, evidence responsiveness, responsive to evidence, empirical data supports it. Evidence should behave in ways that are theoretically expected. Again, my dear friend Javier, right? It has to be within a theoretically meaningful context in that sense. And the last one is coherence, not nomological coherence. There are the 4 sort of defining properties, right, of this mapping. One moment here, my closing remarks. The process product distinction provides theoretical clarity. I think that works. I think the consideration of what is process and product and the blurring of them. I begin to. I'm both absolutely excited by this idea and absolutely terrified by what can be done with it. And so I do worry a great deal about it in that sense. And so do others in here. Bottom line, we got a validity mapping. It's not statistical formula. It's this integrative. And I'm talking the process part. The process part. We are reifying some of these ideas. No, and I think, again, to the speaker just before me, where, you get papers saying, well, I'm doing exploratory work. Of course you're doing exploratory work. But even John Tukey would say, and I was in the room for some of the, knowledge at state 0 is not 0. If you are showing pictures of things and you don't even know what they are, you're not doing exploratory data analysis. You're fiddling around with pictures. Nothing wrong with storytelling and narratives, But, let's be a little bit cautious here. These mappings are important, and we are doing some of it. There's no doubt about it. I think we're doing some of it because of how the algorithms are presented. The AI, ML, whatever algorithmic approaches, they're often described and presented as black boxes. And that, I think, sets us as human beings to think in black box ways. All right, off my ethical issues, I think is important. I think Messick becomes very important in all of this. Again, it's a paper that's next on my list. Anyone want to jump on and work with me on it, send me an email message, and be prepared to get long emails at 3 a.m. from me talking through some of it. I've written about Messick's work for years, but consequences and ethics are absolutely vital to all of this. It's in the title of the session, and that consequences, that validity is not merely a technical or statistical property. It's a unified judgment, and that separating technical validity from consequences is incoherent. Connection to process data framework, Messick's work actually anticipates mine in a rather bold, egotistical statement, how something in the past can somehow anticipate something that not coming in the future. Time is now going this way, not that way. I hope someone laughed. Process data matter ethically when they reveal constructed relevant strategies, inequitable access, or unintended response demands. Ethical concerns emerge, ethical ones, not from consequences alone, but from those consequences, but what those consequences reveal about the response processes, not response data, and construct interpretation. Explanation, prediction is the bridge between empirical evidence and ethical judgment. And that becomes very important here. We need to have, again, there's a whole body of work I've written, contributed to a little bit to it, this abductive sort of reasoning, inference to the best explanation is where I sit in that sense. And it's the bridge between empirical evidence and ethical judgment. But there's also a special case of consequences. We're thinking of process scores alone. What can we learn from those? Well, you can get differential outcome, group disparities, you can get classification error. Yes, there's measurement error in process data. Just because you have a clock on your computer does not mean that you don't have measurement error. And facetiously, I said to one of my students once that the only reason we started with response time is because the machine that we use to record has a clock that measures it to a whole length of numbers. You really think it's accurate that many digits out? If you do, I have a bridge between Vancouver and Asturias, Spain that I need you to buy. It'll be cheap, a couple $2 billion, no problem at all. Really? Really, there's no misclassification errors? Spare me. But they rarely show, right? We have all these things, but they show why these outcomes occur. So all of a sudden we have, Brian and I and Naomi and others talked about neurodiversity. It's actually an interesting case point around some of this. And in educational testing, special education context, we see these differences, we homogenize, then we say, oh, well, actually, these people are different. This is right up Messick's alley. We need to, don't relive and reenact our histories. He pleads like the old man in white hair in the corner. Without the why, there's little to safely and ethically say. We run into problems of misuse of group labels and incorrect categorization. That's my last slide. I hope that this meeting and others, and that my silly finger wagging is meant, I hope, playfully, but also not to be ignored. And I want to thank you all, Britt and David and everyone in the audience. The first speaker was absolutely wonderful, and I look forward to any questions or comments, and breakfast, which is around the corner for me. So,
yes, thank you so much, Bruno, especially first thing in the morning, your time. There's a lovely comment in the chat that probably speaks to many others. We're ready to take questions now, but I just thought I'd start by reading that. I've learned a lot from your presentation, lots of readings that I need to read this after this presentation. Thank you for your Informative talk. And a bravo from Brian as well. It truly has been a great series, and you've made a great final speaker for us. And I know we overran, but I felt it was important to you, given the content. And it's a testament to you that I think everyone stayed online as well.
Oh, that's well, you know, it's a Friday. It's a little slow, and it's actually lovely to see. There's some names that I haven't seen in a while. I think that Timo's on, and I think I saw Javier on a little earlier. So it's lovely to see everyone as well.
Can we take any questions? There'll be a lot of working through of thoughts after that presentation, but does anyone have any immediate comments or questions? Qiwei, please go ahead.
Well, thank you, Bruno. Your wonderful talk. Actually, there's quite a lot of knowledge inside, and I really appreciate it. Actually, David didn't cut you off, so because I so enjoy that. I just want to hear all the things there, even though that is relatively long. So, but we can take the video recording and then to share with the audience who cannot really keep to the end. I have a quick question or comments here to check whether my understanding is correct, because in your slides you mentioned that to say both observed and latent score should be remain distinct from each other. So
no, sorry, my apologies. Both the real set is the construct needs to be considered distinct from either observed or latent scores. So either one of them.
I see. Yeah.
So because there's such a close, as you know, such a close relationship mathematically between the observed total score, for example, and most predicted scores, predicted latent variable scores, particularly like IRT score, the thetas or something like that. So the distinction is really from scores, be they observed total score or item scores, or a predicted, and I remember I used the term predicted, which is technically the correct mathematical term. There's only one model in which you estimate theta. It's right. It's in a Roche model. The other ones are all predicted, and so the observed score, the theta score, those needs to be considered distinct from constructs or the phenomena itself.
Okay, so because before we don't have any process data, so we can use their responses to say yes or no, whether they make a correct or incorrect, and get their score as a kind of observed variables here. And these observed variables will contribute to the latent ability estimation. Yes. And then now we have the process data. So because the process data is also kind of observed information in, so this kind of observed information in will also contribute to the latent score estimation.
Well.
So whether I can think like that way, or
that's certainly
that's
one
rationale.
Right. That's certainly one. That's certainly one use of process data is to somehow supplement the reported score. Let's call it, be it an observed total score or a predicted theta score, right? In IRT or some latent variable score, factor score in a factor model. That's just now. So you went to an interesting place where a lot of people want to talk about these days, which is to use this other information in the function to create a latent variable score. Right? So you now want to add this, and we have a whole bunch of theory in statistics and mathematics around ancillary information, ancillary variables, right? So we want to use these ancillary variables, we want to use these auxiliary variables to help get a better prediction. We're going to define better. Let's define better. We'll decide on what better means in a while. In that, see, that's one use, right? But before we get there, Britt, we first have to lay some claim about the validity around response processes. If not, we're running into the big data problem, which is you're adding all kinds of information perhaps it's salient, perhaps it's not salient, right? So what's missing in that, in what you're suggesting and others are suggesting, and I like what I have some affinity to that, although I begin to caution, is that if we're going to add it in the mix, in the formula to get a predicted, right?
Mm-hmm.
Well, that has to have some meaning. So first of all, we have to establish it's some sort of claim around its validity, the strength of its validity. Let's assume we have, okay, which is now the point where you're at, which says, okay, now response data becomes part of the either ancillary, auxiliary kind of variables that we would go into the prediction of a theta. We've already been down this road. Mm-hmm. At ETS, if I remember correctly, Britt, you're home. Don Rubin's been doing this. Don Rubin has been doing this, right? We throw, and you ask Don, you know, and remember, for Don, everything's missing data, including an estimator, right? And so Don would say, oh, well, throw in, you know, 600 variables, throw in 500 variables, throw in 50 variables. And I would, and it was really fascinating because there's all of this criticism about, and some beautiful, lovely sort of formalism around missingness, the type of missingness. All of that goes out the window when now we're just going to throw in, do some set of components, singular value decomposition, right? You get one dominant component, you get a predict, and there's your score, right? So I begin to worry about some of these, but and now maybe you can say, Bruno, you're worrying too much about it. Maybe I am, but to include it in the estimator, if you wish, you now have to think about what is your estimand. Is it still the same estimand? Got it? Mm-hmm. Now you have and then you get an estimate. And so if what is our estimand? Has it changed? Our estimator now has this set of vectors that are response process data. And if they are not valid, could additional data harm an estimate? Well, most people believe no. But it can sure harm its uncertainty, its standard error. I hope this is of some use to you, Britt. Maybe we need to have this as a separate conversation.
I see of that.
And that's the change in the estimand, right? Yes, yeah. Absolutely. Yeah, that's mine too. And I think, again, it's one of those cautions. I know Eduardo well enough that no one wants to be a wet blanket on these ideas. I think the excitement of it is there. A little epistemic humility, what we know, what we can't know, what risks we're taking. Let's not label people. My family came over to the United States from the south of Italy, and they were labeled all kinds of things because, they enter the border, classic example, and all of a sudden they're speaking in English. And my mother, with my three oldest siblings in the early 1950s, said she's mentally incompetent. And you're thinking, mentally incompetent? This one was far from mentally incompetent. She was, functioning, going around the world with, not speaking the language. And you're thinking, we've lived this history. Let's not live it again. Right, Eduardo? Let's not live it again. Let's not live it again.
I completely agree with you. Yes.
Yeah, thank you for very constructive and inspiring discussions and dialogues over here. So thank you so much for joining us today. So because it's a time, we're already over half an hour. So thank you for the audience that still keep online. So you see, that is the final series for our collaboration in the Georgetown University and King's College Symposium series. So we have the first of three. We have the three series. So I list over here. So it's really great to have our speakers and audience join us every time. So all together, we have a total of almost 400 attendees for our series. So that is a great number. And so you can see our three flyers. We all together we have invited 9 speakers over here and to discuss about this important new data source process data in large scale assessment. So thank you so much for your attention, and thank you so much for sharing this kind of information out. And you can use that QR code, because that QR code can directly direct you to the access for the slides and also the video recording for everything. And so that is kind of our knowledge deck. So thank you so much for joining us. We're so proud of this collaboration, and also so proud to have our audience and also speakers to join us. Thank you so much, and have a very good holiday season.
Thank you very much. Yeah.
Thank you all.
Thank you all.
David and Britt, reach out at some point. David, in particular, some questions you had and others. I'd love to follow up. I'd really love to follow up.
Thank you, Bruno.
Thank
Great.
you
So,
all. Bruno,
thank
I
you.
will wait for you in Asturias.
Oh, it's gonna be lovely. Take care.
you.
Say hi to your family for me, Javier.